this is one of the most advanced topic, analysis of cable supported structure and tension membrane structure, on which I am giving some idea. Okay, this is already my biodata already mentioned. Area of research work, publication of books given. Just highlight, just on the right corner, you can see I got patent for one research work. So we are throwing all our mineral water bottle here on the in garbage. So that mineral water bottle with a special treatment, it can be used in concrete for achieving strength. So this was my topic, and since 9 months I was trying for patenting this research work, and it was granted just a few days back only. And the other patent also in pipeline, that is on the bullet train. So these are new development. The list of client already discussed. Then we are doing all type of consultancy work, so that is related here. Okay, now let us start actual topic, that is the cable supported structure. Cable supported structure may be a structure. So we will see all the details one by one. Now the first of all, here one of the finest bridge constructed in India, having 480 meters span. So that is a China River Bridge. Of course, it is not a cable supported structure, but let me highlight, because it is one of the tallest. Which from the river, you can see from the valley, the height of the structure is very large, and it is one of the tallest, coming under the tallest structure, and it is a railway structure constructed by Indian engineers. When the workers are working here at a very high altitude, the speed is also very high. It is about 150 kilometers per hour. So the main difficulty in construction of this bridge is to work at 160 kilometers per hour. And the human safety is more important. Of course, it is already completed by our Indian railway engineers. And all the why I'm highlighting that we are also constructing very, very complicated and many other different structures. Okay. Then the other one is one of the longest bridge, Tatara bridge, having 1200 meter span. So it is shown here. Other structure we'll see later on. You can read this all PPT I will give you, so you can refer afterwards also. Now, apart from this one, the architectural beauty is also very, very important. Like here, one of this bowstring girdle bridge is shown in Thane. When also famous, the Gestel Millennium Bridge. Originally, it was called as the Sun and Moon Bridge. If you will open out in 2002 literature, you will find Sun and Moon Bridge. Okay, so it is you can see there are a number of cables are there, arch are there. So it can rotate. The bridge can be rotated on pivot. So actually, it is a pedestrian bridge, but it is attracting world tourists for this mechanism. Okay. So when you want to highlight your city, like a Surat having a one cable stayed bridge, so from the structure also city can be highlighted, like a Twin Tower of Malaysia, Agra Taj Mahal, so on. Okay. So this is one of the finest structure I can show you. Then here there are many other aspects for the cable stayed bridge advantages. Like here I am showing you that this bridge, you can see there is the bank of the two pylons are constructed. Okay, it is from France. Two pylons are constructed on the bank of river. So the cost of cofferdam can be saved, and there is no pillar available. So from the safety point of view, so it is good. Now here you can see number of columns are given, number of pillars are given just to support this one. But this will try to reduce the oscillation of the center span during seismic oscillation, earthquake, and this one. Increase main increase span is possible. Safety point of view also it is possible. It will, if I am not using more pillar, then also from safety point of view, it is a good one. Okay. Then taller bridge also because of the development of software. The taller bridge are also possible. Later I will show you different example. Getting stronger means now it is possible to go for a very high strength concrete. Okay, we are just talking in Surat M20 grade, M40 grade, but the world record is 160 and 180 grade of concrete. Okay, there are ultra high performance concrete material available. There are, we can say, the powder concrete available. There are nano concrete also developed recently by China. So these all are just equivalent to concrete. We can say the concrete, the comparative strength of steel and concrete are almost over. because of development of material. So we are going for a very strong material slowly, and that's why the construction of a tall structure is possible because of the new development of material that I want to highlight. Then the precast component is also one of the new concept. So here you can see the case study is given that in a very few hours, 43 pillars can be constructed in example from Dallas. You can see all the precast components are there. This is the pile cap. These are all the precast component, all the ready-made made in factory. And in one day you can erect one pillar. Okay, the precast very high at a huge speed. The precast unit can be assembled and the bridge can be constructed. These are some of the new concepts. What in India, at least for the bridge, the precast component segment is not still popular. Only for abutments. Recently, I got one or two projects in India-Pakistan border where we are trying to introduce a precast abutment wall for the box culvert bridges. So new material already we have discussed. There are FRP, fiber reinforced plastic decks are also available. Corrosion free. Stainless steel materials are also used. Many new material you can see here. It is highlighted. Increasing durability. Okay. These all materials, stainless steel and other fiber reinforced plastic are also durable. Okay. So we can increase the lifespan of our structure. Electrically, isolation is also possible just to protect corrosion of reinforcement. So all these technologies are now available and we can go for a very large structure also. Now, as far as the cable supported structure is concerned, the very historical background, if you want to see, that these are some of the sketches taken from the textbook, Carnegie Mellon University, some architectural studio. So these are one concept is given that the building can be constructed like this. It's a very old one, about 1850 roundabout. So you can see just like when you take a command dokla from the market. Okay, what that seller will take, it will put in piece of paper. Okay, all material, your command dokla, everything, and just bind here and there. Okay, that is a cable. Okay, so basically, what is the concept? That here in the first picture you can see the building is just wrapped by a different cable. Okay, and we can say that the building is safe from this one. What is the mechanism? So mechanism is shown here. You can see the cross section view is shown here. That there are two pillars are there, which is taking compressive load from the top of this pylon or the top of this pillar. The cables are taken and the roof is suspended from this one. So it's a suspended roof concept. Okay, so very basic. Some of the theory was developed and slowly it is turned into a cable straight bridge. So you can see 1853. The concept was available in 1853. This was the name of architect. So the roof is suspended. You can see there are two strong pillars, maybe a wooden and the steel chain are used because cable was not available. Rope chain, steel cable. So if you will open out Encyclopedia Britannica and other thing, you will find that these are made up for taking a tension reinforcement in arches even. They are using a steel chain. Okay, so here steel chain and this one. And the roof structure is suspended totally, and the last one structure can be erected. So this was the case of 1853. Then in 1865, this is one of the big pavilion is developing, just like a circus. Okay, in circus also we want a tent type of structure. So you can the ground supported cables are used. So these are some of the early 1865, 18th century, 19th century examples in which cable are used for the structural engineering. So here also the one gymnasium is shown 1960, 1958. Okay, 1972 also cable supported Olympic Stadium was constructed in Tokyo. If you can open out Google photograph, you will find number of photography in 1972. Number of we can say the stadium are constructed with cable supporting structures. Even the cable supported bridge are also constructed like this. It can be openable. If I will try to operate here. Rotate this one, the bridge can be open for the navigation purpose. So these are some of the earlier examples of historical development of cable supported structure and cable supported bridge. So these are one of the very simple mechanism. So here you can see how suppose these are very simple. Only one cable is shown just to understand the behavior of cable supported structure. So here the one car is passing from the bridge deck. So whatever the loadings are there of car are transferred through this tension cable up to the top of pylon. This for pillar or pylon, whatever you can say. So by the compressive loading, it will just go to ground and from the foundation by piling or by isolated footing, you can absorb this compressive loading. So you can see a very simple mechanism. There are all three components of the truss: tension, compression, and again compression. That will give me the basic fundamentals of cable steel bridge. You can even increase the number of cable also. So that is shown here. That is shown here. So a tension and compression mechanism are shown just like a behavior how load are transferred. The cable can be parallel or cable can be radial. So if it is a radial, then it will be. Hello, please close your mic. Hello.
Yes, sir. Please continue. Sir, please continue.
Cable. It may be a parallel profile like this. It may be a radial profile like this. Okay, each are having some advantages and disadvantages. So from the research paper, you can go into detail of this one. And here also the mechanism is shown for the basic test compression behavior. Hello, आवाज आया है ना?
Hi, yes, sir. Yes, sir.
Okay.
I request all the participants please mute yourself. Yes, sir. Please continue, sir.
Okay. Now, if you will open out ETO or the textbook for the cable steel bridge, then it is classified into the various arrangements like a mono, harp, fan, and star. So each are having these advantages and disadvantages are shown here. Okay, the end condition when you go for computer modeling in Midas or SAP software, the different end conditions can be used like end pin, roller, pin, roller. So these are just for the computer modeling. So different assumptions you can take for the computer modeling. Okay. When we say a cable, so cable is not one drop. Okay. If you see Surat cable steel bridge, any cable steel bridge, it is not one cable. It is a conglomeration of number of cable. So it has a different arrangement, which are shown by these 4 diagram. Correct. Here number of diagram, 23 diameter cables are there. Number of 7 mm diameter cables are there. 15 mm diameter cables are. It is wrapped inside. And the strength is ultimate strength is almost 3 times. You can see if I will compare with FE415, it is FE1500. So it is almost 3 times than whatever we talk about our structural engineering steel, FE415 or FE500. Almost 3 times strength is there. Okay. The most important thing that it will withstand, it is written here that 2 million cycle. The most important thing, whenever you use cable, when you want to construct cable steel bridge, the cable is to be tested for the most advanced cyclic loading laboratory, and it is tested for 2 million cycles. It is written here 2 million cycles of the reversible chassis. In India, no laboratories are available, but in USA, in Singapore, and in Switzerland, 3 laboratories are available, which will give you certification for this 2 million cycles loading criteria. So our Surat cable steel bridge was also tested in Zurich laboratory in Switzerland. Okay, and then it was used for by OVM company, and then it was used for our Surat cable steel bridge. If you will do modeling of the cable bridge in the software, okay, so it will look like this. It is from my PhD only. Okay, you can see the pylon and different colors are there. Hello. So the first simplest form of the cable steel bridge is called self-anchored bridge. The 605 meter span. The center span is 605 meter span, and these are the different supports are given. So it is written here without ISS, means without intermediate side span support. If I am putting here extra support, this is the main span for the navigation purpose I am using. But here, if here in the side span, if I am putting some extra support, then it is used for it is called with support. Means it is a different category of a bridge. So here with side span support, what I am explaining from the France. Okay, earlier also I have shown you. So here you can see number of pillars are given, number of extra pillars are given. This will not only reduce the bending moment in this pylon, bending moment is used in pylon, but also reduce the oscillation of the center span of the cable steel bridge. Okay, so that is with intermediate side span support. Means here in the center span there is no pillar, but on side span I am using a number of vertical columns. If I use real bi-state type of bridge, in bi-state type, what we are doing from the top of the pylon, we are directly earth anchoring, 2 extra cables are given. Okay, 2 extra cables are given. So during earthquake and wind oscillation, this will not allow the movement of the top of pylon, and some pin connectivity is developing. So that definitely my designing of the pylon will be economical So it is called bi-state type of bridge, bi-state type of cable steel bridge without intermediate side span support. In PhD, you know that some innovations are required. So this is one of the very innovative idea I have proposed, in which the triangle pylon are used, and proved that this is one of the best option for cable steel bridge. Of course, there is a construction difficulty in construction of the top of this beam, but otherwise this particular type of pylon will give very optimum solution from earthquake and wind oscillation point of view. Okay, so these are theoretical. Theoretically, it is proved in my PhD work. Now, if I will use word bi-state with ISS support, means here you can see the bi-state cables are also there, and intermediate side span extra supports are also given. So, out of all the category, this is one of the giving the most economical and sustainable solution from earthquake oscillation point of view. Okay. So, when you want to test the cable steel bridge in computer software, a different earthquake loading time history is to be applied. So, in my PhD, I have used 3 type of time history: a long, medium, and short span. Long time history, that is for the Bhuj earthquake having 109-second earthquake. Then El Centro from the USA, 39-second medium level earthquake, and the Koina, only 7-second short duration earthquake. In earthquake, you have to remember the duration is also very important, as well as PGA, that is peak ground acceleration, means what energy earthquake will give to structure. That is peak ground acceleration, that is very important. So this both is to be considered designing, and where the PGA will occur, at what time it will occur, at what time have highest impact on the structure will be created by earthquake. So that is also to be understood by time of the PGA value. So if you will open out, if you will give seismographic record, this Bhuj earthquake will look like this, having a number of epicenters available. So it is called widespread, long duration, widespread distribution of the earthquake. Okay, and between one peak to second peak, you will find 10⁻³ second, -6 second, means in 1 second time, the earthquake shocks will hammer your structure 10 lakhs time. That is the meaning of the line. Similarly, for El Centro, medium duration impact type of vibration you can see. And similarly for Koina, almost uniform earthquake observed in 1967, short duration earthquake but uniform wave. So all this type of 3 wave pattern will give you different effect in cable steel bridge. Please remember, okay, this is not, this is called no, it's called, but no 2 fingerprint of earthquakes are equal. It is different, always different. So that is highlighted by this 3 diagram, that all the 3 earthquake fingerprints are different, and it will give different oscillation in cable steel bridges. So when I will trigger earthquake shocks at the base of cable steel bridge, then you can measure in computer software what is the displacement of the central deck in X direction, Y direction, and Z direction. So just for understanding the time, this is the time duration, and when I will continue displacement will took place in cable steel bridge, and X, Y, and Z, all the 3 diagrams are superimposed just for understanding. Similarly, bending moment in base of pylon will also change continuously. So my bending moment in shear force also change continuously as according to the earthquake forces acting in bridge structure. You can also plot response spectrum curve considering fundamental time period and pseudo spectral acceleration. So that diagrams are also plotted. These are all the output of SAP software. Automatically it will generate, and you can study the earthquake behavior for this bridge. Then if I will consider spread pylon bridge with 19-degree inclination, this is a 19-degree inclination, different inclination was studied in my PhD. It will look like this. It is shown here. Okay, this is just an AutoCAD diagram, how we are generating, what are the property of different material, what is the height of pylon. That is geometrical parameters are explained by this architectural view. When you model in software, you can see that this is a spread pylon. This is a pylon. This blue color also indicate pylon. Okay. Then these are the different cable. Cable is supporting at 2 ends by truss. These are truss. Okay. And between 2 truss, I am putting a steel rod, and then I am putting a box section with steel section just to create a box type deck. Okay. These are the damper position and link element that will avoid the oscillation of the cable steel bridge. So this is a single line diagram just to explain that how to model in SAP software, just to understand. When you apply a free vibration analysis, model analysis in cable steel bridge, then for 0 degree and 30 degree, how it will oscillate in mode 5, that is explained here. More displacement will be there, here less displacement is there. So that proves that it is giving less displacement during earthquake oscillation. It will also behave similarly, just like a mode shape. Now conventional A-shaped pylon bridge, which is widely used in field. So that is explained here. And in PhD, we have to go for some validation of software. So for validation of software, I have taken a WinZinc paper done for the same and in ANSYS 3D software. The same geometrical property shown, it is taken from the research paper, and the same geometrical property I have analyzed in SAP 2000 and model and proved that my reading and WinZinc reading are equal. Okay, so these are validation part. So whatever fundamental time period I am getting, fundamental time period divided by one frequency of vibration f is equal to 1 by t. So that will give me the value of fundamental vibration. So you can see that WinZinc is giving this much reading. It is from the China, the paper taken from the Chinese author. In my work in SAP software, same model I am doing, so I am getting almost equal, and it is called validation of software. And after that, the complete work was carried out in SAP software. These are again a SAP Pylon geometrical architectural view, and the dimensions are shown. Same is repeated here. So in SAP Pylon, how cable straight bridge will look, that is shown here. So these are very big SAP Pylon, different position of pylon, a different position of cable, pylon, truss, box section, everything is shown here. Okay, you can zoom and you can see. So if I will zoom the image, you can see that what is the created. These are the truss element. Okay, these are the position of the cables which are pin jointed with this truss. Okay, and the different I section are taken just like a purlin thing, and then steel plate is kept on top and bottom just to create a solid box section type of thing on from which my vehicle will pass. So in modeling, if you will go for line diagram, then earlier image will be there. If you will fill up with the geometrical property, then it will look like this in computer software modeling. So it is the line element filled with the geometrical property of section, concrete and steel and cable. It will look like this in SAP software. Okay, three-dimensional image is taken directly from the SAP software for SAP Pylon. The central part of the deck of cable steel bridge are very vulnerable during earthquake oscillation as well as tornado and wind cyclone. So it is to be studied very properly. So very detailed analysis was carried out, particularly at the joining part, central part, because these cables are load transferring on the other pylon, and these cables are transferring load on the other pylon. So these are very sensitive during earthquake, and wide study is required. A lot of care is required at central part because it is far away from the support. And the different mode shapes are compared with intermediate side span support, without intermediate side span support, and how it will look in mode 1. Both are compared. Self-anchored bridge. Similarly, bi-state with intermediate side span, without intermediate side span supports are compared in mode 5. How it will look. Then mode shapes are plotted. Mode number, fundamental time. These are the mode number and fundamental natural time period. Okay, time period are superimposed. Bi-state, type, self-anchored, different, and you can conclude something that which is rigid, which is flexible, that you can identify from the basic behavior of this graph. Okay. After this 4.5 year work only on one topic, I have derived particular equations in which for any unknown, you not to go for computer software calculation, but if you will, you can just put here that any unknown peak ground acceleration, any unknown earthquake oscillation, peak ground acceleration you can put, and you can calculate EDR, that is earthquake displacement ratio, or indirectly, what is the displacement, central displacement of the deck during earthquake. So without computer modeling, you can able to predict directly, you can correlate for the vertical direction, how many, up to what extent my bridge will oscillate during earthquake for this much PGA, for lateral direction, and similarly for A-shape type pylon. So these 4 equations I have developed after 4.5 years of research work, which will give me a very concluding idea, the central displacement of the bridge versus peak ground acceleration modeling. Now here just for what is the different rigid bridge, you can see a very solid steel sections are used. In the case of flexible bridge, okay, so in flexible bridge you can classify basically in 2 categories, that is cable steel bridge and suspension bridge. In the suspension bridge, directly the cable are taken from the main cables are taken from the top of pylon to the ground like this, and the hanger are used, and then the deck is there. In just February month, I have visited the same places and taken number of photographs for the same bridge, Akasi bridge. Now you can see the center span is 1991 meter for suspension bridge. Okay, so actually it was planned for 2000 meter, this one, but during Kobe earthquake, the both pylon were shifted by 4.5 meter, and that's why the span is less 1991. Central clearance for the navigation is 65 meter, which I can put below cable steel bridge 20-story building. So it is so high, I think you can imagine. And the cable diameter are also very large. It is almost 6 feet. The diameter of main cable is almost 6 feet, just like a human height. Now the world's tallest cable-stayed bridge, this was taken from the Paris-Barcelona cable-stayed bridge. You can see the height of pylon is 343 meters. It is higher than Eiffel Tower. And our earlier photograph I have shown for that for the railway bridges, which is constructed in Jammu Kashmir by Indian Railway, is also a very large height. It is I think higher than this one. It is not 343. It is higher than this one. But, and the span is also 342 meters. Here you can see a fiberglass. Seats are provided so wind will not try to overtopple the vehicle passing from the cable steel bridge. So it is also called Mila viaduct. You will find number of videos and the different details. You can see the height of Eiffel Tower is 300 meters, while the height of this cable steel bridge is 343 meters. Okay, so it is taller than Eiffel Tower. And the pylon was constructed with fiber reinforced concrete technology. Using slip form technique, the pylon was constructed with fiber reinforced concrete technology. So during earthquake and wind oscillation, it will deviate here and there. Energy will be absorbed by fiber reinforced concrete, and nothing will happen to cable steel bridge. Really, it is really above sky, and you can imagine what is the condition of worker working at a so much great height. And these are the different stages of construction. These are the whole for the cable steel bridge construction. So these are the temporary support. These are on the piling support. These are the temporary support. After construction of bridge is over, it was removed. Okay, and these are different sequence of construction of cable steel bridge. And after finishing this bridge, you can see from the aeroplane how it will look. That is shown by this diagram. The pylon are classified into basically 6 types. The first 3 are called low level for the low level bridge or the river cable steel bridge. So it can be used like a twin pylon or the portal pylon or the A-frame. It is actually deck on which my vehicles are passing, and the dotted line indicates the position of the cable. These are the deck A-shaped pylon, and this is a high-level bridge in ocean. If I want to construct, the single pillar are used, single delta and diamond, and these are the decks. These are very small deck. You can see as compared to the pylon, my deck is very small on which my truck and other vehicle will move. So these are for the deep ocean. Technologies are different, so that's why it is shown like this. While in the on ground, it is different. Technologies are different. Now here what is the definition worldwide of cable steel bridge that I want to show you. So here the very special shape you can see of a cable steel bridge just shown here. Each having a very specific scientific advantages from earthquake and wind oscillation point of view. The first one is taken from the Jordan, having V-shaped pylon. This is a V-shaped pylon. So center of gravity can be maintained here. This is the Millennium Bridge. I think in Jab Tak Hai Jaan movie in Shah Rukh Khan, you have seen this particular bridge is in London. So here, because of the design error, some vibration dampers are provided at the base of this bottom part for avoiding this wind oscillation, or when the pedestrian traffic will move, it will vibrate. So for that, this bridge is very famous. Then this is from the Thailand. You can see the complete mechanism is on the shore only, and the fully cantilever structure is there, and the 3-dimensional network of cables are used. In this Italian bridge, you can see the dampers are provided at the top of the pylon and cable connection, and the earth anchoring was used. The diamond San Francisco bridge having a diamond shaped cable steel bridge. This is a Russian bridge. It is famous for the lighting during night time. The different lighting patterns are, so it is attracting world tourists because daily I will get a different lighting pattern on the cable steel bridge. That's why this Russian bridge is very famous and very popular also. Is one of the other structure are shown here, A-shaped pylon from the France. Here in the Argentina, the top cable is very large diameter. It is just like a trapode we are using for the surveying from the Greece. Okay, Rio Antirio bridges. Okay, in which the self balancing mechanism is used, and these are continuous long span bridges constructed by China. Correct, one longest cable steel bridge inside ocean. Now recently we are talking about for earthquake oscillation avoiding, we are talking about dampers and this other arrangement. Okay, but now in 2004, Dr. Abel Hassan from USA invented new technology. Okay, What he says that you design structural shape such that it will be self-balancing mechanism. So just for example, this Malaysian air bridges, where the 2r by pi, you know, the center of gravity of line are lying at 2r by pi. We are teaching at first year engineering mechanics level, engineering mechanics subject. So if I am putting my pylon, my support at 2r by pi level, that this is a very self-balancing mechanism, and safely earthquake energy can be absorbed by this curved bridge. So these also constructed by our defense purpose for the high altitude mountain road in Himalaya. No foundation directly, rock will used for hanging bridges. The last one is very, very interesting. Brazil cable stayed bridge. You can do two springing action of a deck. The deck, when during earthquake will occur, when horizontal oscillation will be there, these two deck will act as the springing action and the energy will be absorbed. So these are some of the very fantastic, very few bridges are available having curved cable stayed bridge profile. So these also, I think in dawn picture, the last scene of dawn picture, that one person is throwing back. So the Malaysian air bridges, okay, at Genting Highland, and here also the 2r by pi concept was used for supporting cable stayed bridge. So these are this type of technology can be adopted. This type of technology can be adopted for near epicenter of earthquake. If you are very near to, if your epicenter is within 8 km ranges, then you have to go for very special step structure just to absorb earthquake oscillation in X, Y, and Z, all the three directions. So these are some of the examples of the same type. Okay. From this one, I have taken a 75-degree inclination. Another type of model, a theoretical study using trapode effect was studied in my PhD, in which the curved shape and inclined pylon having 75-degree was used, and it is safe from earthquake point of view, that was shown. Then we have another fantastic bridge from safety link bridge of Singapore. Okay, so here you can see the complete bridge is in hanging condition. It is just like a अपने गुजराती में तराजू कहिए, okay, just like a palm balance. The whole bridge will oscillate here and there during earthquake, and nothing will happen. Even the backstay ground supporting cables are also given. So these are one of the finest bridge safety link bridges of Singapore is shown. Then the curved cable stayed bridge also from my PhD. You can refer my volume and papers in which the backstay are there in SAP modeling how it will look. So that is shown here. If I will apply earthquake loading on the curved cable stayed bridge, how my oscillations will be there in X and Y, Z, that is shown here. Okay, with backstay, without backstay, how mode shape will change, that is shown here. With backstay, without backstay, here backstay are provided, here no backstay are there. So how during earthquake, during free vibration analysis, it will move. So that is shown here. Mode number, this is a mode number 5, number 7, how it will be there in 7 mode. Okay, then in 16 mode number 16, vertical, this one will rostral bending will be there. Please remember that in cable stayed bridge, the first 5 mode are giving only the first 5 mode are generated only by the pylon. The other next 5 means 5 to 10 mode are generally developed by the oscillations of the deck, and the remaining 3 after 10 mode of vibration, whatever analysis I am doing, so vibration will be mainly observed in the cable. So there is a basic difference between all the 3. That's why more number of mode study are required. Like a suspension bridge, we have to go up to 32 mode of vibration. In cable stayed bridge, first for 15 mode of vibrations are sufficient. And recently, I am also committee member for tall building project in Surat city. So we are going up to mode 12. Up to mode 12, we are checking for the building stability analysis, and we have checked up to 85-meter high structure in Surat city. Now, these are some of the unique bridge designing. You can see just like our Kashmir, that musical instrument, harp. It is just like same shape is used for in Spain by the cable stayed bridge. It is the ice cream cup type of cable stayed bridge in Switzerland. And here also from the Malaysia, that fish is coming from the water. That is the concept. And here you can see 2 dampers are provided and 3-dimensional network of the cable just to avoid oscillation of the cable stayed bridge is shown here. These are few unique designing. Already I have discussed the sun and moon bridge in my first slide. You can see the full. It is now open and all the pedestrians are here. Publics are standing and observing. These are some of the world famous structure. Okay. Now, if you will talk about a very simple structure but very fantastic from earthquake and wind oscillation point of view, then my favorite shape is this one from the Brazil. You can see the bridge is straight. The bridge is going straight, but the intersectional arcs are used. Intersection arcs are used. You can see intersection arcs are used, and which will by supporting cable, you can avoid the earthquake and wind oscillations of the cable. Very, very, very low cost. very low cost bridge, at the same time very safe and giving fantastic view from architectural point of view. So these are some of the very finest shape which are where world are going and where we are. So we have to construct this type of remarkable structure in India also, just to attract world tourists. Okay, it is not a bridge, it is a world tourist attraction structure. Please remember. So these are again a different view are shown. This is another view where the coffee shop is there. You have to pay a very high rent here because it is a hanging structure by cable. So there is a coffee shop available. Hello. Please stop your mic. Hello. Please stop your mic. Hello.
Yes, sir. Continue. Sir, continue.
Yes, sir, continue.
Mic बंद करो उनको. Now here the ball pen stand type of cable state is shown here. Now here these are the two bridges where you can see it is S type of bridge. S type of bridge. Here wherever land is available, wherever again I am repeating, wherever land is available, I am putting pylon, and the bridge profile go as per the geometrical profile of the highway, and then you connect with cable. So I am getting a spider net type of supporting structure. This can be analyzed in SAP software, and you can see a fantastic shape. You cannot repeat because these are peculiarity of this particular traffic junction. Okay, so instead of going for the court cases in Surat में क्या होता है, court case करते ये करते वो करते, don't go for that. Wherever I am getting space, put your pillar, and wherever let bridge travel fly as per the requirement of the highway engineering requirement. Connect with cable and design. So this, you will get this type of very fantastic shape of cable. Okay. Then here also different views are shown. Here truss and cables both combined. Truss and cable both combined are there. Here I think arch and the cable are used combined. The name of this bridge is Namaste Bridge. Means you can see the two pylons are inclined and welcoming the entry of a ship. When they will enter into country, they feel that it is a Namaste. Means two persons are standing and just holding hand. This is a view of a extra dose type cable stayed bridge on Narmada River. So these are shape already constructed by cost of 354 crore by L&T company in Gujarat Narmada River. So this is also extra dose type, one of the finest step. This type of structures are also available in India, and many structures are along highway are constructed like this type of arch and cable combination. So arch is also there, and it is hang. The deck is hang by the cable from the arch, and okay. Now, when I'm talking about extremely large span structure, okay, the combination of the cable stayed and suspension bridge is required. So one of my PhD students, G. Ghanshyam Bhai, has worked. So here we are trying to combine cable stayed bridge in which directly the cable supporting are from the deck to this one, and the suspension bridge, one big cable is going, and the central part here also these are cable stayed bridge, these are cable stayed bridge, and the central part is suspension bridge. So the name of this bridge is cable stayed suspension hybrid bridge. They're combining both technology, and we have tried up to 1.4 kilometer free span. 1.4 kilometer free span we have tried and proved that by this technology it can be constructed also. So these are the different study taken from his PhD work. Sag of cable, suspension portion also you can change. The 1.4 kilometer central span, side span 0.7 kilometer, 0.7 kilometer. So these are the architectural view and the SAP software view shown. Different parametric study was conducted, like a suspension to main span ratio. Suspension is this much and the main span is large. Suspension to main span ratio, different arrangements are shown, and it will behave differently during earthquake and wind oscillation. Then cable seg to main span ratio, if I will change, how it will look, span by 10, span by 8.5. So how my diagram will change, so that is explained. Each are having some advantages, disadvantages. And in designing, you have to optimize design and then you have to construct bridges. Now, these are very typical extra dose type of cable stayed bridge. What is another PhD student? He is presently chief engineer, Mandar Sar Desai. He is a chief engineer in Stup Consultancy, Bombay. Okay, he's done PhD under my guidance. So in extra dose type cable stayed bridge, my height of pylon is very small. My height of pylon is very small, and that's why I think more than 12 already bridges are under construction in India by extra dose type technology. And the deck will also take a major loading. So these are the different view, architectural view are shown for extra dose type of cable stayed bridge. Now, what is the difference between cable stayed bridge, ballast cantilever bridge and extra dose bridge that is shown here? The first diagram is called ballast cantilever bridge, which is constructed on the Narmada River. That damaged bridge I am talking about, in which the pre-stressing cables are passing from the top. Okay, and the ballast cantilever are there. Okay, now if for increasing, so lever arm is only small, but if for increasing lever arm, if I am taking cable out and increasing for increasing lever arm, I am just constructing some pylon like a cable thread bridge. So what happens, instead of straight cable, now cable are outside my bridge, and it is called cable thread bridge. And for increasing lever arm, I am putting my pylon here. Okay, now in between ballast cantilever bridge and cable thread bridge, if my height of pylon is 1/4, suppose ye h has h by 4, if my height of pylon is 1/4, then what happening, the major loading, my lever arm is also smaller, but major loading will be also taken by the deck, box girder, and the cable and the pylon. All the three will work. So that is called extra load cable side of bridge. So the most important thing that here it has the advantage of cable thread bridge also. At the same time, it is also very economical and cover large span. That's why it is more popular. And using this technology of extra load type of cable thread bridge, our Narbala River extra load type of cable thread bridge was constructed with same technology at cost of 354 crore cost. So these are the different view of extra load type of cable thread bridge that is shown here. In SAP modeling, how it will look with different arrangements of supports pile that is shown here. It is developed by my PhD student Mandar Sir Desai. So how it will look in mode 1, 2, 3, 4 that is shown here. Okay, mode 4, 5, 6, 7, 8. How it will look. Okay, it is a first extra load type of bridge of the world in US in Pearl Harbor Memorial Bridge. It is in Pearl Harbor Memorial Bridge. The technology was first initiated and then it is copied worldwide. So first bridge was constructed in US. Now India already, I told you, many bridges are under construction or many completed also, like a Narmada bridge. Another student, Jigar Variawala, is presently working with a bullet train type of thing passing from the cable thread bridge. So two students are already working under me for bullet train. One is Pooja Rao. Also some patents are applied for patenting. She is studying a geotechnical engineering aspect. When the bullet train will pass from the South Gujarat, what will happen to soil? So for that, modeling and other things are done. And the Jigar is working with the cable thread bridge when the bullet train is passing. So here you can see another bridge is shown, even this is a bullet train passing at a lower deck level, at a higher deck level. It is a two-storied, for single-storied structure. You can see constructed with a truss, and the cables are passing here, and here is for the highway. So top portion is used as a highway, and bottom part is used as a railway track. Okay, so in India also many bridges are available, but not cable bridges. Many ordinary bridges are near Visakhapatnam, near Vijayawada. Many bridges I have seen in which multi-level bridges are used in which the top portion is used for the highway purpose and the lower portion is used for the bullet train. In Thailand and Singapore, many bridges I have seen in which only single cable thread bridge, single pylon is used. But the 3-layer I have seen, not 2-layer, 3-layer. Means the BRTS bus are passing, then the roadway are passing, and the train are passing. So it is a 3-story structure. It is possible to construct. But in India, I think up to this month only we have constructed. But in foreign country, they are going for the multi-level bridges. Okay, so that is shown here. The box type of truss is the completed bridge is shown with the cable thread bridge. From the top, highway is passing. From the bottom, the bullet train is passing. Now, if you will go for intricate mathematical formulation, so very few papers are available in which the cable thread bridge and with the dynamic loading of the bullet train combined considered. So here, all this property we are taking from the mechanical engineer, where there is a contact of railway track and wheel load. So the damper property and the axle loading, there's all mechanism is copied from the mechanical engineering part. So now we are developing a combined model. When bullet train will pass, how mechanically it will transfer the load, cyclic loading, it will transfer on the railway track. How the cyclic loading on the railway track will be transferred in the cable thread bridge. So that is the study part, and we are trying to develop a different model. So according to this literature review, when the bullet train engine will pass, it will give me 176.4 kilonewton passenger car loading and 103 kilonewton load I am getting when the passenger car will pass. So locomotive will give me more loading, passenger will give me less loading. And presently we have also done one of the structure for Surat, near Surat, near Magho village, the Reliance pipeline is passing, and for protecting underground Reliance pipeline, for the bullet train, 3 structure were erected, and it was designed by me. We have designed and it is already executed for bullet train project in Surat city area. We are also working for Ahmedabad metro project, Ahmedabad metro railway project. So these are the different arrangement, and how different compositions will be there. So it is the Desai has used this particular model for validation part, Queens Bay Bridge model from the USA. So how it will look, different eye sections are there, how geometric profile are there, and here these are the positions which is supporting a complete bridge. So this particular is for the validations part. Later on, he tried for a different parametric study with a different pylon shape influences, like a H shape pylon. Then you can say the H shape pylon, A shape pylon, Y shape pylon, diamond shape pylon. Different pylon inclination with beta degree angle is taken. It had a span is same, everything is same. Pile cap, piling, pylon, deck, cable, everything is shown in naked view. So just you can understand how the load transfer will go. Okay, so for the same loading, for the same cable straight bridge, for the same train, bullet train loading, how my different pylon will behave differently, and which one is the most economic way after considering Surat earthquake oscillations and the wind oscillations. So that is the main purpose of this PhD work. Now we'll see the construction process for this one. You will see in a video. It is in Jammu area, Jammu Kashmir. SP Singla Construction Company has erected this bridge. 592 meters span, total length of bridge, 106 meter height of pylon, 13 meter width of road. You can see the connections of pylon and deck, cable, everything. We can also introduce the monitoring system. When the vehicles are passing, how my bridge will oscillate. The monitoring is also possible. For recently, Dwarka bridge also monitoring mechanism we are trying to develop. The piling work is there. Enforcement, group of pile, construction of pile cap, inclined pylon construction, concrete, self-setting concrete, self-compacting concrete, SCC, self-compacting concrete, reform technique construction, abutment part, so pylon is ready now. Abutment is also ready. Now deck is built. Top of the deck plate. Floating pontoon used for further construction. Okay. Yeah. So I hope that you have seen this video. Now this is also different other various cantilever construction for this bridges, different type of other type of bridges. Now please remember that construction sequence is also very important. When you design any structure, no, it can be the cable bridge cannot be constructed in factory and ready-made. So you have to go for each construction stage analysis. So each this like this here This ballast cantilever construction, this on both sides continuously we are doing simultaneously. We are constructing just for balancing the loading. But here, suppose during this incomplete condition also earthquake and wind oscillation will occur, nothing will happen. So that is called construction stage analysis. So that is also to be carried out. Okay. Then the light ray transit technique here you can use the deck is constructed in factory and it is pushed completely. The bridge is pushed, segmental bridge is pushed completely from the factory side by hydraulic jack, and the bridge a bridge can be erected. These are the suspend cable. It is for segmental box construction. This is one of considered to be one of the most difficult tasks in construction of bridge. So recently, one bridge is already under construction on in Narmada River by segmental box. So this you can see there is a launching girder available. We are also constructing one segmental box girder bridge in Kota. Okay, where the 20 segments are used. It is precast full and bridge. It is precast, and the after lifting, after hanging the all deck here, the gluing will be done. Okay, here gluing will be done just to fix up this trunk and glue arrangement. Cable are passed, and after pre-stressing, my deck will take load. Okay, so the same segmental box construction technique was used in Bombay Worli Civil Link Cable Steel Bridge. Same technique was adopted in Bombay Worli Civil Link also. Okay, so these are some of the difficult bridge construction in which launching girder are used. These are the other full-scale spanning launching girder. Like in Korea, you can see 400-ton component, 600-ton bridge segment is constructed in factory. It is lifted on the truck, full top of the truck. Then by lifting by this launching girder by crane, then it is lowered and the bridge was completed. So these are some of the very advanced now new techniques for construction of the bridge structure. Okay. Then here in Jakarta, you can see the traffic is ongoing and the full bridge is constructed in this factory, and it is pushed above this one, and it is pushing completely without disturbing traffic. The complete bridge is pushed. Similarly, other examples are also shown. Here also the pushing is done. Okay, and these are also the same technique Korean photograph I have shown earlier. Then in Kerala, recently using launching girder, a segmental I section was constructed. You can see the I section is there, very strong I section. Above this one, a segmental I section were kept like this. Okay, segmental I section were kept. Then it is fused with a concreting at a junction, and the pre-stressing cable was passed from this one, and then it is pre-stressed, and the segmental deck was erected, and then this particular bottom part was removed. Okay, so these are also new technique developed. New technique developed in Kerala, in India, in which in a heavy lifting techniques are used. Okay, so these are another technique. Recently, in Jim Corbett Park in Rajasthan, we are constructing a pedestrian suspension bridge. So these are the actual photographs. Recently, in lockdown period only, we got this work. 44 meter span, 44 meter suspension bridge span. So these are the position of the piling suspension bridge. A hanger will be there, and the suspension bridge are stored in the local station earth in ground by piling action. So whatever tension is occurring in the suspension bridge are absorbed by this earth station on left and right side. Okay, and these are the actual computer modeling. And earthquake and wind loading was considered from the Rajasthan. That location is in Jim Corbett park. Okay, and it is a pedestrian bridge. It is not for the public, but it is for not for the vehicle, but for the pedestrian bridge. And recently we have done this work for Rajasthan project. This is my photograph, my other professor photograph. So in Kota, every month we visit, and we are this is a launching girder, and the segmental box construction bridge are under construction. The bridge construction was done by Vijay Mistry of Gujarat. Vijay Mistry, one of the big company. They are constructing many bridges, even in Surat also. This Pylon bridge also under construction by Vijay Mistry. So we are doing work for them in which segmental box are used. Now these are another one of the finest project done by us, a butterfly bridge. Okay, butterfly bridge, the complete component. This is a 60 meter span bridge. Span is 60 meter. It is constructed with complete stainless steel tube. The diameter of main tube is 1.2 meter and the small tube are 900 meter. Okay, the stainless steel tube, instead of cable, the stainless steel tube are used. Okay, and the bridge was constructed. It is in Dadra Garden near Selva, Swapi. Okay, the cost of this bridge is 14 crores, and we have done the third party inspection work also, proof checking work also, designing many aspects. Almost 2 months time required to just to check this one bridge. Okay, but we have constructed. So this is the first, India's first stainless steel supported stainless steel butterfly bridge in India. अभी ये पहला ही बना है. Still inauguration is remaining, but bridge is already completed. So if you have a chance to visit, please visit this fine structure in Dadra Garden near Silvassa. India's first stainless steel butterfly bridge. Instead of cable, stainless steel. These also you can see stainless steel tubes are projecting just to support deck. Of course, it is a pedestrian bridge and different views of this. Now Dadra Garden already work is ongoing, and the name of company is Rachna Construction, who has constructed this bridge, stainless steel bridge for our country. Now we'll switch over to some other aspect. So now I will talk about now we'll talk about a different structure which supported by cable. So it is also called deployable structure and tension structure. Okay, deployable structure is our umbrella. As for example of umbrella. Our umbrella is a very simplest form of deployable structure in which you can open and you can close. Okay, now here on the right side, the one structure is shown having a cable 17 meter by 18 meter umbrella. Okay. It is in Medina. Hello. Please stop talking. Hello. Darshan bhai.
Yes sir.
So 17 meter by 18 meter umbrella.
Sir, you are muted. No, sir, you are muted.
Ma'am sir, please unmute the sir mic. Ma'am sir. Yes sir. Sir. Wait. Wait sir. Technical issue.
हेलो हेलो
સર નો અનમ્યુટ કરવાનું છે તો અતુલ સર નો.
હા એક મિનિટ સર ને કહું છું. હા સર તમે છે ને અનમ્યુટ થઈ જાઓ.
someone has कोई क्या अनम्यूट કરી દીધા સર ને.
ઓકે નાउ ઓકે.
હવે બરાબર છે?
હા યસ સર.
એટલે હમણાં આ સ્લાઇડમાં થયું કે આગળથી થયું આવું?
ના ના હમણાં જ રિસેન્ટલી
આ સ્લાઇડમાં આ સ્લાઇડમાં.
હા સારું ચાલો ઓકે. So here deployable. Now tensegrity structure is another variety in which cable and steel member both are used. As for example, for solar panel used for satellite, okay, in which in geostationary orbit we are closing our all solar panel, and when after launching our satellite in geostationary orbit, the solar panel will open. So in tensegrity structure are used. It is designed by structural engineer. Okay. So you to just operate one cable. So if I am pulling that cable, my tensegrity structure will open, and in a full form it will be look like a solar panel. So that is a basic difference between deployable structure and tensegrity structure. But here I am just showing a deployable structure. Now this tension membrane structure, in which later on we will go in more detail. So it is now the most recent trend in architecture and giving a very beautiful as well as very economical solution. So we'll go what now in tension membrane structure, we are also going for pre-stressing. Okay, pre-stressing of cable. So the different layers are there. When we will take a Teflon sheet something, so one fabric will be there, then there will be a number of protecting material on both sides. First layer, second layer, third layer, final color. So these are tension, whatever cloth we are using for tension membrane are having a very specific property. Okay, the netting and wrapping are having two directions. One is called wrap and one is called wrap. Okay, direction. So here you can see a tension membrane is passing here, and the particular for pre-stressing purpose, the wrap yarn are used, which are to be pulled for stressing the particular roof element, and here in other direction. So two directions are shown. One is web direction and other is wrap direction. Okay, so these both are different property, and but in the principal direction you can go for a main cloth. Okay, that is the purpose. Now here there are three processes required in designing of processing of tension membrane structure. First is the form finding. Means first of all, architect or the engineer has to finalize that in which form I want membrane. So after finishing surface, what finished surface I want, correct, basic static shape of the structure that is to be finalized. Then you have to go for structure analysis, that in this form, what are the loading coming, what are the snow load coming, what are the wind loading coming. Earthquake are naturally here very less because it is a very low weight structure. Okay, and the patterning means you have to apply a three-dimensional pre-stressing in membrane element, and then it will give me then it is to be transformed in 3D to two-dimensional pattern. After pre-stressing, it will achieve three-dimensional pattern. So it is something like this here shown. This form finding that I want a membrane. I want a membrane of this type of this particular type of structure, like a cylindrical membrane. If cylindrical membrane I am pulling in the central part, then again second curvature, hyperbolic curvature can be achieved. Okay, this is the original form. If I am pre-stressing in the central part, you will get again a sag element like this, and you will get a final form like this. And here a lot of traces will be there, that is to be balanced by some structural element. Now in this form, when you apply a wind loading and different loading, snow loading, you will find a different stress contour. Means it will give me what is the tensile capacity required in this zone of this particular flow. What is the tensile capacity required, and what is the other loading required. Now I will cut this all slide in a different slide form, and then analyze independently what is the pre-stressing required for the top membrane, what is the pre-stressing required in the central part, and then finally after putting all this linear element, I will apply pre-stressing cutting pattern generation. I will put here in this cut arrangement. Okay, it is a monolithic, but here theoretically you to study like this, and we will apply a different pre-stressing force in this particular line element, and ultimately you will find this form finding. So that is the basic difference here, because pre-stressing force will change my profile and it will give a different shape. That is the fundamental. Now basically it is classified tension membrane structure in which cloth and tension cables both are used, are classified into different varieties, like a flat surface are shown. Okay, then syneclastic structure are there in which it is just like a mountain. Anticlastic structure in which a valley type of things are used. Okay, so both are material is same. Please remember the material is a flat surface, but we are giving a different pulling and pushing effect, and that will try to give me a different shape of the same clothes. Okay. So here it is written here, anticlastic surface is a negative Gaussian curvature. Is a mathematical Gaussian curvature is a mathematical term. Okay, it is just like a your y is equal to mx plus c, whatever equations of line we are using, y is equal to x square, y is equal to cubic parabola. Similarly, Gaussian curvature 3-dimensional also having a specific property available. Then cineplastic surface positive Gaussian curvature. So these are mathematical term. Okay. Now if you want to go for a very extraordinary type of thing, then hypermodel are used. Okay, here like a simple rectangle are there, suppose, or let us take our square handkerchief. Okay, now in handkerchief to opposite end I am lifting in square handkerchief I am lifting to opposite end to higher altitude and to opposite end of other handkerchief but at a lower level, then I will get this hypermodel type of thing. Okay, very fantastic. It is a rectangular piece of paper, but when I am lifting two edges to high level and two edges to a lower level, I am getting a very fantastic slab like this, and then it is analyzed for further calculation. Then what are the load combination to be considered? So pre-stressing force are used, self-weight pre-stressing plus no load. Then wind load is to be considered. In India, wind loading is definitely predominant. Then snow load, if it is in how high altitude mountain, then snow load is also considered. So here one of the master student has worked and the objective was finalized. Now for this particular thing, our SAP or other software are not used, but this is ReLAM. The name of software is different. ReLAM. Okay. So this name of software is ReLAM, in which is all geometrical property, everything you can finalize. You can apply a pre-stressing forces and you can check your design calculation also. So this ReLAM software was used particularly for this type of tension membrane structure. Okay. So these all the commands are also shown. And we are working, we have recently, I am also working for Surat International Airport, even in Amritsar Airport, Surat International Airport, Guwahati Airport, Bangalore, Goa, many airports we have done with this tension membrane structure. The name of company is a Western outdoor company. So we are doing a lot of work for Western outdoor company. So they erect, they design also. So with their help, we have used this. We have developed use this ReLAM software for further calculation. Okay, so this is a very specialized software are used. Okay, so here this is taken from one of the paper. Okay, so you can see a rectangle piece of paper, a stretch. First of all, stretch in 4 corners having 6 meter dimension, and then lifted to high point, to high point and to low point like this, having 6 meter by dimension. The lifting is taken as 2 meter. 2 meter distance, and you will get a very fantastic shape of a structure. So already that is shown here. Now what is the direction? What is the pre-stressing force we are applying in cloth in wrap direction? What is the pre-stressing force applied in wrap direction in cloth? So that is mentioned here. Cable force are also mentioned here. Modulus of velocity, the other property, rigidity, Poisson ratio, snow load, everything is mentioned. Please mention, and it is used for further calculation. Then the results are compared. This is the validation part, of course, taken from this research paper. This is a research paper taken from 2013, and the property was achieved, and the same property was entered in the ReLAM software, and the MTech student has worked, and the validation was done that she is getting Sneha, she is getting almost equal result. Just 1 minute. So she has worked for 2 type of shape. One is a basic cone shape. Okay, here one circular ring is there, bottom circular ring is there, and the different D, if I will take and different stretching pre-stressing force apply, I will get a different profile in a conical shape, and in hyper shape also I will get a different. So this both profile were checked. So geometrical variation was done for hyper shape and conical shape. H by D variation means height to diameter ratio is changed. How it will look. So different model are taken in hyper model shape. You can see a rectangle piece of a square piece of paper. All the supports are at the same level M1. It is called model M1. Okay. Then I am slowly lifting this opposite to end and trying to develop the stresses indirectly. Trying to pull the stresses. If I will take higher level, then model M3 will be there. Still I will go for M4 model, then M5 model. So if you compare M1 model and M5 model, material is same, प्लीज रिमेंबर, ये भी रेक्टेंगल है और स्क्वायर है, यहाँ पे भी सेम है, but because of the lifting of two end and lifting of this one, because of the stretching of the cable, I am getting a very fantastic architectural hyperbolic type of structure, hyperbolic loop type of structure, which is architecturally very very beautiful. You can see the material is same, everything is support भी यही है, अरे उसको आपने lift किया and I am getting a very fantastic shape like this. Okay, similarly, if I will go for very high M6, then you can see another parabola. ऊपर cubic parabola हो गया, hyper parabola हो गया, and नीचे again I am getting another parabola. So the you can see original M1 is same, and as soon as M2, M3, M4, M5, I am changing the height, I am getting a very very fantastic shape from the same material. Architecturally beautiful material I am getting. Okay. Similarly, conical shape is studied. Okay, so basic cone is here some circular ring is there, circular ring which is supported by the solid element from this support to this support. So that will try to hold circular ring in the position, and between this bottom part and top part, the surface is stretched. Surface is stretched. Okay, and that will the precessing force will transfer ultimately to this cable or here in ring form, and ultimately it is transferred from the solid element to the foundation. So that is the fundamental. So if I am changing the height of the cone, you can see a different shape I can achieve, C1, C2, C3. So different cable arrangements are shown, different membrane arrangements are shown. C6, C7, you can see the broader, the flat, it is a flat type of thing, very flat type of thing. But as soon as I am increasing height, I am getting more and more complicated models. Okay, so these all are applied, and then now very speedily we will see different graphs. Of course, it is a very detailed graph plotted by my student. Okay, so what are the parametric variation possible? Okay, first of all, membrane pre-stress. If the cloth is same, I am just changing the membrane pre-stressing forces. The different shapes can be achieved. If I will change the sag of cable or the permanent structural element. I am artificially taking up and down. Then sag can be achieved. Different modulus of velocity. Even you can combine two different materials also. One of the project recently in Dubai, the outer near the seashore, the outer body, we can say the wall was constructed not from the masonry or not from the RCC, but the cloth is used. Both type of structure. The cloth is used. Okay, the cloth is used by one of the Japanese architect. Okay, so even in building, in exterior cladding, people started using this membrane technology for lightweight, because you know the earthquake forces are slowly increasing in South Gujarat. So if I am good, instead of masonry RCC construction, if I am taking a membrane structure having a very lightweight, then your designing will be definitely economical, as well as it has a very large advantage of a architecturally beauty. What is the rigidity and poison ratio? So these are the different parametric study we can take. So she has taken a different parameter for different models and varied the comparative chart for cable deflection, cable stress, web stress are studied. Okay, the hyper shape was also studied. Different parameter. This displacement for one particular model was taken. So this all parameter study was conducted. Deflection, and all the parameters. So you can see that even if out of these 5, any one parameter I will change, the configurations of the structure will be different. The behavior during bead oscillation is also different totally. Okay, so these are a deflection graph, cable stress graph, web stress are shown. Vertical reactions. What are if I am taking a different configuration? Naturally, the reactions parameter at ground supports are different. So that is also shown here. Vertical reaction, horizontal reaction. Similarly, just for your knowledge, I am also building was committee member for South Gujarat Ahmad University. So one of the pavilion structure we are now constructing with this cable supported membrane that we are already 4 supports already architectural design was passed, and now under design stage. So we are also constructing a large span structure in here in South Gujarat. If you will if you will go enter into the realm software, what output it will give you? It will give me a deflections contour like this. You can see a very very detailed deflections contour. Okay, where stresses are developing, because of the where the more stresses are developing. So you have to select appropriate material for this loading. So this membrane will not collapse. Membrane will not turn off. That is the basic intention. So all the model reading are conical model and the hyper model are shown with reading. Different graphs are plotted. These are the concluded remarks that you can study later on in detail. These are lying in my cupboard. If you are interested, you can refer. Okay, conclusions. Okay. Now, this is one of the my first example. You know that whenever some tall building, any we want to study for the wind loading, so normally everybody will insist. Even ISO committee will say that we have to go for wind tunnel testing. Okay. Now actually in India there are only 4 wind tunnels available, and ये आपको line में खड़ा रहना पड़ेगा. After 6 months, the minimum charges are, I think it is 10 lakh rupees per structure. The cost is also very high for wind tunnel testing. So for avoiding the difficulty, my student, PhD student and master student, we have tried to develop a CFD modeling, computational fluid dynamic analysis in software itself. There are in NCS also it is possible, and now in Midas wind dynamic software also it is possible to go for this type of analysis, computational fluid dynamic analysis. Okay, so it is giving a very accurate reading as compared to wind tunnel testing. For proving that technology, my first work I got from the same company, that Western Outdoor company. So they are developing one of the Mila complex fabric structure in Calcutta. It is one of the mold structure. So outer periphery, you can see outer. This is a real project. Just 6 months back we have done this work. So outer periphery, the tension membrane structure was erected just for architectural beauty. But now the shape is so complicated. Then our IS code 875, wind loading is silent for this type of shape. So we have conducted a CFD study, computational fluid dynamic study, and instead of wind tunneling, we have applied in domain and calculated that in this complicated shape, how my wind pressure will change, where in cavity, what are the stresses developing because of the wind stresses, and what material you have to take, what amount of pre-stressing force you have to apply to develop this type of a very complicated geometry. So that was done. The first work done in my 36 hours span using computational fluid dynamic analysis we have done for one of the consultancy projects. For research work, we have done many work. Also, we have designed 120 meter world tallest hybrid windmill for Suzlon industry in Rajkot. That also we have done long back. But these are, as far as CFD is concerned, this is my first work. Please remember the CFD are also used by architects department. So in your close climate, suppose I am starting AC. So how my air conditioning blow will give different cooling effect in the this one. Or suppose the building subjected to fire. So how my fire will, or suppose building subjected to bomb blast. Okay, how my blast wave will propagate in building. So all this type of study is possible with computational fluid dynamic analysis. So I think this is one of the finest examples we have done for Kolkata project. Okay, these are the different views you can see. These are the in ANSYS software, how when we apply we blow wind blow, then how my wind vortex will developing in structure, where corner will try to generate a vortices, where more care is required in structure. Everything is visibly on screen. You can see this is taken from the same consultancy report we have given to client after final study on computational fluid dynamic analysis. So this is one of the finest work we have done, and these are the different projects worldwide or even are also in India already constructed. You can see the finest, like a Rajiv Gandhi International Stadium. You can see some tension membrane structure. Dr. Bhupendra Hazarika International Cricket Stadium. Also here, many work we have done with the Western Outdoor Company. Surat Airport also we have done. Surat Airport we are designing. Indoor Cricket Stadium also it is done. Ranchi International Cricket Stadium, you can see. Correct? Ranchi में भी बनाया है. Okay, the top roof is very good. So Rajkot International Cricket Stadium also you can see all the tension membrane structure. Some are solid element, pre-stressing are applied in membrane, and some are cable element. At the border you can see a cable elements are provided. Lodha Cricket Stadium, Dombivli in Bombay, ये भी बनाया है. You can see a very, you can imagine what amount of main is uplifting pressure. अभी recently we have also done work for a Kochi International Airport for Bhopal, in which a temporary structure with membrane we have erected, and it was done. The proof checking work was done by us just 10-15 days back. Kochi Airport हमने करके दिया. So these are during lockdown period. So we are busy with our consultancy project. Okay. These are for the Goa Airport, what I was talking earlier. So Goa Airport, you can also see a very fantastic membrane structure. So now, even now, I think this is another view. Even I think one or two now in railway station also. I think in Varanasi and other the tension membrane structure started application of tension membrane structure in only railway station, not in airport. In railway station also slowly it is penetrating. When you will travel on highway also, whenever there is a check post available for toll, you will find a tension membrane structure. So many type of this new technology are now started in India also. Is a Rajkot airport departure. This one you can see tension membrane structure. Pune airport में भी लगाया हुआ है. Even in Bombay also you will find similar structure. Okay. Then even for the mall, okay, 10-acre city mall in Ahmedabad, you can see there is a truss element available. There is a hanger steel rod is available just to support this mechanism partly. So it is supporting your the basic structural system. Okay, and in between two truss, here I am using a membrane structure. Membrane structure are also pre-stressed to get a different. If I will give us more stretching, the shape of this particular cavity I think change. Okay, so this is another example. Mole roof with a membrane structure. Another structure developed in Banduk in Bombay. Okay, so tension membrane structure is transparent tension membrane structure is also possible. So even daylighting also possible. At the same time, it will give protection against wind. In Surat also many projects are going with tension membrane structure. The other architectural beauty for school project. Okay, pedicure is for school and universities. So already I have mentioned that in university, we are in South Gujarat University, we are already finalized all the details as a building work committee member. And so I think in next year, after 6 months time, you will get that fantastic structure in our Dakshin Gujarat University in Vesu campus. American School Bombay, okay. Mahindra World School, here also tension membrane structure and other elements are used. Bosomia University, Jaipur, Gujarat. Then open air theater activity, outside student. So here in the university also we are constructing open air theater supporting structure. And Mahindra School, you can see a very good playground available, free supporting structure. It is giving very good architectural beauty also, and even student can learn. In school children will be motivated by the structure. It is for motivation purpose. If you are always in a brick structure, architect structure, then when you will go in 5-star, you will enjoy the wooden structure. You will enjoy this type of fantastic shape. Okay, that will try to change your brain. Okay, brain activity also. It will give me a very good idea. So these are for school children also, and university also. Different forms are used. Okay. Then the American School Bombay, you can see some parking area is there. Then Ambikapur, this is also one of the very good structure developing at a very low cost. You can see how only cylindrical membrane is used here. The star pumps are also very popular. Inside, outside, even it can be used for temporary exhibition. Inside, outside exhibition center 2003. Okay, mega show. Okay, it can be used for temporary structure. After your mela is over, you can remove. So this is another advantage. Then Dholera में भी ये बनाया है Dholera. Okay, Dholera, you can see there is a one truss is going from the top, and the different supporting system are there. The another truss is inside this one, and the other is the tension membrane structure, and the bottom part here the cable are passing. Okay, in Sitapur also one of the structure are shown here, having a very specific shape of column, just like a trunk of a elephant. Thank you for question listening.